Alright, so firstly I'll talk about how my character lecture on the background. So firstly, how we draw on it is we're using the RT whiteboard. So this is a set of pixels so we can draw upon. So you can see here, we see a white here. So every time the character will draw a white in here. So next is I create a material whiteboard. This is how we see it outside in the game. So this is the RT whiteboard where we draw onto. This black one is the color of the how we want to draw, and this is the color of the background. So what I do is I multiply the RT whiteboard with the parameter, so it will get all the white pixel inside of texture sample. Multiply with black, so we get this black pixel, and then the outside black pixel of the RT whiteboard will get blurred with the white, so we get the white outside. So that's why you can see this black and this white outside. So I apply this material whiteboard into the BP whiteboard. So this is actually the object outside. So this is the wall. This is actually the background outside. You can see here there's a dot in here indicated the character is standing right here. And then in the event graph, so when it starts, I'll create a marker in here. So it's a dynamic material instance because the marker needs to move around to draw onto the background. So when I create it, I will save it in here, the whiteboard marker, and then I will reset the RT whiteboard every time I play the game to the black color, so you can see here. Next is it also have an event where we get the location we want. So in this case, we will always get the location of a character on the background. We pass it through here, we pass it into the whiteboard marker so it can draw. It draw on a location, and then we use draw material on render target. It means that we override the RT whiteboard with the whiteboard marker. So it means it draw onto RT whiteboard with the white color. So how my RT whiteboard marker work is in here, I get the location of it. I get the location. So in here, I save the X and Y location inside of the RG. So I must getting the RG out. And then I subtract by 1, it just modify it. And then I pass into a vector. And I subtract this vector by 1 so it can fit into the screen. And then in here, I getting the draw size. The reason why the draw size is so small is because I'm using subtract and divide in here. It means like when you scale the background up like 100 times, you need to scale the draw size down 100 times to get the actual draw size of the character. And then after clamping and dividing, I have the location and the draw size, and then I will put them into another whiteboard marker so it can be used to override inside of this function. Next part is how I detect it. So every second, we will detect the location of the character on the background by using light trace by channel. So this actually like this light trace by channel actually do is getting like a location, and it is getting the end location. So if anything that is in between them, it will get that actor and get that location, and it will return it back. So in here, I did get world location is get the world location of a character, and we will scale. It will measure it down to minus 5,000. So it will on the y-axis. So it will detect anything behind the character. So in this case, it will be the location of a character on the background. So and then it will return it. So it will return it as the actor, and it will send the actor to a whiteboard. And also, the fine collision UV will detect the hit where it hits, and it will get the location of it. So all of these will send all of them into draw on whiteboard. It means this event, so it will get a location, so it can send into the whiteboard marker and draw onto the RT whiteboard. So this is the result of how it draw. Next one, I do some like very interesting as well. So first one is the state of the character. So you can see here, the character will have a multiple state. So when it's moving, when it's jumping, when it's ducking and moving. So in here, you can see that I'm using, so in here is where it jump. So in here, I'm detecting like it cannot jump while crouching. So crouching is pressing C. So when the player is pressing C, it cannot jump. And then when it jump, it would change the state of a character to jump and play some sound. When it stop jumping, stop. So when this event on land is detected whenever the character is landing on the ground, it will set the state back to the aisle. So in here, for each state, there will be a different animation. So I will set the flipbook of character. So in this case, it's the aisle. So whenever it's moved, it will be moved. But whenever it jump, it will change the state to jump. So we can see here, there will be jump, like jump and duck right and duck moving. So how I'm making, so duck and move is actually pressing C and the moving key at the same time. So this is how I detect it. So it's C. This whenever the D or the right is pressing or the left or A is pressing, it will detect it and get into this branch and will set the state to the duck right and duck right, for example. And then the character will crouch, and then because the crouching here is setting the hitbox of a character to like very small in the middle of the character, so we need to move the image up a little bit so the character can see that the player is still on the ground, not under the ground. So when the player is uncrouching, we'll set back to the crowd, it will uncrouch and we'll set the image back to the location. So I'll show how it looks like. This is here. You can move like this and move like this. So this duck right, because our character is 2D character. So duck right, when it moving right and we move left, it's actually turning the character. It doesn't really matter how it works because it's actually turn the character. So in here you can see, and it can also jump like this. Also, I'm also making the character changing to white. So whenever it falls to this thing. And I also making the main menu of the game and the levels, well, it's not so interesting, so